In this video, we will learn about topic 9.2, Centroid of Composite Bodies. Centroid of Composite Bodies. Objective is to calculate the center of mass, center of gravity, as well as centroid for composite bodies. These are the standard shapes, and their centroid locations are defined in terms of x bar and y bar. These are different shapes with their area as well as x by y bar location. And now the composite body in this section refers to a body made up of a collection of simple shape parts or holes. The composite method for determining the location of the center of gravity of a composite body requires very simple arithmetic. So we don't need to do any integration here, it's a simple math. Applications: the I-beam or T-beam shown here are commonly used in various types of structures. When doing a stress or deflection analysis for a beam, the location of its centroid is very important. How can we easily determine the location of the centroid for different beam shapes? So this beam is made up of three standard shapes: one horizontal rectangle, one vertical rectangle, and one horizontal rectangle. This is made up of two shapes, horizontal and vertical rectangles. So we can in composite bodies, basically we simplify the shape using a shape made up of standard shapes and then calculate the centroid for each one of these shapes individually using the overall coordinate system, and then apply simple arithmetic to get the centroid of this entire shape or composite body. The compressor assembly shown here is made up of many individual parts. Now, in order to properly design the support at A and B, we would like to calculate the support reactions, and that's only possible when we calculate the centroid or the center of gravity for this entire assembly. Now, the one way to do that is if we know the weights of individual components, such as 1, 2, 3, 4, 5 here, and we can find out the centroid of all these individual components relative to one coordinate system, which is here x0 located here, x0, y0, and then apply the concept of composite body theory for centroid calculation, then we can solve this problem. So the formula is really simple, that a composite body overall centroid is calculated using the sigma rather than integration. So it's simple arithmetic where it's x tilde multiplied by w for each shape, where sigma indicates each shape. So if it's I section, then there are three standard shapes, two rectangular and like two horizontal rectangle and one vertical rectangular shape. So it will be like x1 tilde w1, x2 tilde w2 plus x3 tilde w3 divided by total w. Okay, and that's, if it is a three-dimension shape, then it's x, y, and z. If it is two-dimension, then it's only x bar and y bar. And if we replace this w by a, area, then it will become center of centroid rather than center of gravity. And if we replace this by m, then it will be center of mass. So remember that for centroid we use area as our base or reference. For center of mass we use m, and for center of gravity we use w in the formula. Many industrial objects can be considered as a composite bodies made up of series of connected simple shape parts like rectangle, triangle, semicircle, or holes. Knowing the location of the centroid C, center of gravity CG of the simple shape parts, we can easily determine the location or CG, center of gravity, for the more complex composite bodies. So in this case, we can see that this, let's say if this whole object is our part, then we can simplify it by part made up of a square shape, a triangular shape, two semicircular shapes, and one like circular hole. So to find the overall centroid, we need to find the centroid for each one of these shapes separately in terms of the xy coordinate, and then apply that sigma equation. If it's a three-dimension object, such as here, it's made up of different shapes, such as like a big rectangular plate at the middle, two triangles, and two small rectangles at the base. Now for this part, we need to add all the centroids, and for here, we need to subtract the centroid for the circular shape. So the following can be considered, this can be done by considering each part as a simple particle and following the procedure as described in section 9.1. This is a simple, effective, and practical method of determining the location of the centroid or center of gravity of a complex part, structure, or machine. So these steps typically are divide the body into pieces that are known shapes. Holes are considered as pieces with negative weight or size. Mark a table, make a table with the first column for the segment number, the second for the weight, mass, or size, the next column, set of columns for the moment, arm, and finally several columns for recording the results of simple intermediate calculations. Fix the coordinate axis, determine the coordinates of the center of gravity of centroid of each piece, and then fill in the table. And then finally apply this formula for x bar, y bar, and z bar, and calculate the overall composite body's center of mass or centroid. Okay, so in the next, I recommend that you go through this like example from this topic after you watch the next video for our in-class exercise. Thank you.